Hello everyone. Here I finished do this in the page number 33 of polynomials for the 9th students, AP and Telangana maths textbook. So next I'll explain the next topic, that is zero of the polynomials. Here look after the here zero of the polynomials. We have to make the in which value the polynomial which gives 0. In which value the polynomial which gives 0. Okay, so we have to find out that values of the next topic. Here look after here example 1 in page number 34. We have example 1. So look after here, p of x is equal to x plus 2 and find p of 1, p of 2, p of minus 1, p of minus 2. Okay, these this value we have to substitute in the place of this x. What are the zeros of this polynomial x plus 2 and which value it gives 0 for this polynomial? Okay, we have to find out that. Okay, first of all, given that the polynomial p of x is equal to x plus 2, p of x is equal to x plus 2, and we have to find out first p of 1. So in the place of this x we have to substitute this one. So 1 plus 2, that is equal to 3. So second, p of 2, so that is equal to 2 plus 2, that is equal to 4. And third, we have p of minus 1, that is equal to minus 1 plus 2 is equal to 1. And fourth, we p of minus 2, that is equal to minus 2. In the place of this x we are taking these values. Okay, so plus 2 minus 2, these two are cancelled. Here we get 0. So therefore here p of minus 2 is the 0 of the given polynomial. Okay, just like that you have to mention. Here we have to find out the which value gives the 0 for this polynomial. Okay, so next look after here example 2. Find a 0 of the given polynomial. Find out the 0 of the given polynomial. Example 2. So given that the polynomial p of x is equal to 3x plus 1. So to find out the 0 of the polynomial, the 0 of the polynomial is, that implies 3x plus 1 is equal to 0. You have to equate this polynomial is equal to 0. Then you will get the 0 of the polynomial. So here that implies 3x plus 1 is equal to 0. That implies plus 1 is equal to, it becomes minus 1 into other side, right? X is equal to, it is in product, it becomes a denominator for the other side, that is 1 by 3. Okay, so here x is equal to minus 1 by 3. Minus 1 by 3 is a 0 of the given polynomial. That's it. Okay, so here minus 1 by 3 is the 0 of the given polynomial. So here look after this example 3. Find a 0 of the given polynomial, just like the above sum. Example 3. So given that the polynomial is 2x minus 1. So 0 of the polynomial, the 0 of the polynomial is 2x minus 1 is equal to 0. So plus minus 1, it becomes plus 1. So that implies x is equal to 1 by 2. X is equal to 1 by 2. Here 1 by 2 is the 0 of the given polynomial. 0 of the given polynomial. Okay, so here we finished this example 3 also. Once look after here in the same page, that is page number 34, we have try this. We will do this just like according to this example 2 and example 3. By this model we can solve these sums also. Okay, try these. So in page number 34 we have try this. So What is the first one? So first one, given that the polynomial is p of x is equal to 2x minus 3. The 0 of the polynomial, that implies 2x minus 3 is equal to 0. That implies 2x is equal to 3. Minus 3, it becomes plus 3. That implies x is equal to, so 3 by 2. Here 3 by 2 is the 0 of the polynomial. 0 of the polynomial. Therefore 3 by 2 is the 0 of the polynomial. So in that second sum, given that the polynomial is p of x is equal to x square minus 5x plus 6. Okay, 0 of the polynomial, that implies x square minus 5x plus 6 is equal to 0. So you just look after here. So x square term and x term, you just take these two and make the product of these two. 6 into x square, 6x square. Okay, so you just take two terms that has to be multiplied. When you multiply that two terms, you have to get this 6x square, and when you add the two terms, then you have to get minus 5x. Okay, just like that you make that values 6x into 1x. So you just keep here minus. Okay, you just keep here plus. So if you took like this, so 6 1 is 6, x into x, x square. So but plus minus 6x minus of minus into plus minus you will get. So just like that you just look after that. 6 1 6, okay, but you have to take 3 into 2, 3 2 6. Just like that you have to choose the table what we have to take. Okay, so when you took this type, you will get minus 6x square. So it is wrong. How we have to write? That is x square minus 5x plus 6 is equal to 0. It is new for you, right? For 9th standard, it is new for you. That's why it is a factorization. It is a new concept for this class. So how we have to choose? So 6 into x square, 6x square, and 6 ones I am not taking. What we have to take? 3 2's. 3 2's. X into x. Okay, 3 2 6, x into x, x square. So I want to keep minus on both. Why? Because so minus of minus plus. Okay, multiplication. Okay, enough. So addition, when you add this minus 3x minus 2x, then you will get minus 5x. Yes, it is now perfect. So it is wrong. So when you are taking the factorization of any polynomials, so you have to choose the multiplication, and that too satisfied for this term, and the addition which is satisfied to this term. Okay, so just like that you have to choose the numbers. So x square, first term as it is you just write, and the last term as it is you just write here. Okay, that implies you just look after here. What is the common term? X is common. So what is remained? 1x is getting out. Okay, so we are taking it as a common. So x is there. 1x is taking common. So only 3 is there. Here in both these two, 6 is 6 is in 2 table, 6 is there in 3 times, right? 2. I am taking 2 as a common. So x minus of minus plus it will become, that's why I am taking here minus. Okay, 3, that is equal to 0. So minus 2x minus of minus plus 2 into 3 to 6. Okay, so in these two terms x minus 3 is common. What is remaining here? X. Here minus 2. That's it. That implies x, you just equate this 2 with 0. Okay, x minus 3 is equal to 0, x minus 2 is equal to 0. Then you will get x is equal to 3, x is equal to 2. So here 3 comma 2 are the zeros of the polynomial, zeros of the polynomial. Okay, understood? You just, when you are taking the factorization, and you have to choose the numbers which is satisfied both these two terms. When you multiply these two, you have to get this one. When you add these two, you have to get this one. Just like that, you have to choose the numbers. Okay, so don't write this one. Coming to this, after this zero of the polynomial, you just write this one. Okay, next, the third sum in this, try this. So given that the polynomial is p of x is equal to x plus 5. Zero of the polynomial, that implies x plus 5 is equal to 0. That implies x is equal to minus 5. That's it. Here, therefore, minus 5 is the zero of the polynomial. That's it. Here, look after here. So after finishing this, try this. After completion of this example 3, we have, look at here. So do this. In the textbook itself, you can do this. There is an empty space here. So x plus, first one, x plus a is equal to 0. X is equal to minus a. Here he gave. Second one, x minus a is equal to 0. 0 of the polynomial, we have to equate this equation with 0. So minus a, it becomes plus a, that is a. Okay, so third one, ax plus b is equal to 0. It becomes minus b, that is equal to, x is equal to minus b by a. Here minus b by a, that's it. Okay, so fourth one, ax minus b, that is equal to 0. Ax is equal to plus b. X is equal to b by a. That's it. Okay. So just like that, you have to do this in textbook itself, not in notes. In textbook itself, you just finish off this table. Okay. After that, so example 4 we have, verify whether 2 and 1 are the zeros of the polynomial or not. We have to substitute this 2 value in this x places, and also we have to check this 1 in x places. Then is these two terms which gives a 0 or not? We have to verify that. Okay. So example 4. So given that the polynomial is p of x is equal to x square minus 3x plus 2. So what we have to check? 2. First of all, we have to check 2. That is p of 2. We have to check. Okay. So p of 2 is equal to 2 square. In the place of this x, we have to substitute this 2. Minus 3 into 2 plus 2. That is equal to 2 square means 4. Minus 3 to 6 plus 2. So these two are positive numbers. 4 plus 2, 6. Minus 6. That is equal to 6 minus 6, 0. Second, p of 1 we have to check. So 1 square minus 3 into 1 plus 2. So 1 square means 1, 3 ones 3 plus 2. These two are positive numbers. Hence 1 plus 2, 3 minus 3. That is equal to 0. Yes, 2 and 1 are the zeros of the given polynomial. That's it. Okay. Look at here. Example 5. If 3 is the 0 of the given polynomial, he was given that 3 is the 0 of the given polynomial, then find a. Okay. So given that the polynomial is p of x is equal to x square plus 2x minus a. Okay. Here 3 is the 0 of the given polynomial. Then p of 3 is equal to 3 square plus 2 into 3 minus a is equal to 0. 0 of the given polynomial, that's why I am equating this 0. That is equal to 3 square means 9 plus 2 3 is 6 minus a is equal to 0. So these two are positive numbers. So 9 plus 6, 15 minus a is equal to 0. We just take out this minus a into other side, that is positive a. A is equal to 15 you will get. That's it. the value of this a is 15. So after finishing this example 5, just look after here, think and discuss in page number 36. Page number 36, think and discuss. Okay, so what is the first question? X square plus 1 has no zeros. Why? So first of all, look after here, given that the polynomial is x square plus 1, right? The zero of the polynomial, that is equal to x square plus 1 is equal to 0. X square is equal to minus 1. X is equal to minus 1 square root. So, but minus square root of, in the square root there is a negative number. For the negative number we are taking it as a imaginary numbers. Here in square root there is a negative number, hence it was imaginary numbers. Therefore no zeros for the given polynomial. Okay, so here second sum, look after here, second sum. Can you tell the number of zeros of a polynomial of degree n will have? Okay, so first of all you just look after when the degree of the polynomial for linear polynomial is 1. That implies which has highest power 1. Okay, so you just, for the clarification I am giving this one. Okay, you just write as it is, degree of the polynomial of quadratic is 2, that is which has highest power is 2. Okay, and so on, just like that. The degree of nth polynomial is also n. That's it. Okay, the degree of nth polynomial is also n. Why? Because why it is an nth polynomial? Why? Because the highest power is n. That's it. The highest power is n. For nth degree polynomial, the degree is n. For second degree polynomial, the degree is 2. For first degree polynomial, the degree is 1. Just like that, nth degree polynomial has the number degree is n. Okay. So now after finishing this think and discuss, we have exercise 2.2. Exercise 2.2 in page number 36. So in first Roman we have, look after here, find the value of the polynomial. We have to find out the value of the polynomial when, so x is equal to 0. First of all we have to substitute x is equal to 0, then x is equal to minus 1, then x is equal to 2, then x is equal to minus 1 by 2. That is 1 by 2. Okay, we have to substitute these x values each and every time in the given polynomial. So in the first Roman, first of all, given that the polynomial is p of x is equal to 4x square minus 5x plus 3. Okay, so first of all what we have to write, x is equal to, if x is equal to 0, that implies p of 0 is equal to 4 of 0 square minus 5 of 0 plus 3. So 4 of 0 square means 4 into 0 minus 5 zeros 0 plus 3. That implies 0 minus 0 plus 3, that is equal to 3. That's it. So second, if x is equal to minus 1, that implies p of minus 1 is equal to 4 of minus 1 whole square minus 5 of minus 1 plus 3. That is equal to 4 of minus of minus. How many times we have to write this minus 1? 2 times. Minus of minus plus 1 square 1 minus minus of minus plus 5 ones 5 plus 3. That implies 4 plus 5 plus 3. 4 plus 5 9. 9 plus 3 12. That's it. Okay. Next, third sum. So if x is equal to 2, you just find out this value. Okay, so you just find out this value, and also fourth sum, x is if you just do by your own. Okay, if x is equal to 1 by 2, so then p of 1 by 2 is equal to 4 of 1 by 2 whole square minus 5 of 1 by 2 plus 3. That is equal to 4 of 1 square means 1 by 2 square means 4 minus 5 ones 5 by 2 plus 3. So 4 cancelled. So 1 minus 5 by 2 plus 3. You just take the denominators of these two as minus. You just do LCM for this. In one table 2 times, 2 ones 2 minus in 2 table 1 5 is 5 plus in one table 2 times, 2 3 6. That is equal to, these two are positive numbers, that is 2 plus 6 8 minus 5 by 2. That is equal to 8 minus 5 3 by 2. Here it is the value of this p of 1 by 2. Here we finished the first Roman. Okay, now we entered into the second Roman. That is, find p of 0, p of 1, p of 2 for each of the following polynomials, just like this sum. So we have to do this one. Okay, I'll explain some sums and I'll give some homework for you. Okay, in the second Roman, first sum. Okay, given that the polynomial is p of x is equal to x square minus x plus 1. Okay, so firstly we have to find out the value of this p of 0. For this we have to find out the 3, that is p of 0, p of 1, p of 2. Okay, that is equal to 0 square minus a 0 plus 1. That is equal to 0 square means 0 minus 0 plus 1, that is equal to 1. So second sum, that is p of 1, that is equal to 1 square minus 1 plus 1. That is equal to 1 square means 1 minus 1 plus 1. Plus 1 minus 1 cancelled. Here we get 1. Third sum, p of 2, that is equal to 2 square minus 2 plus 1. That is equal to 2 square means 4 minus 2 plus 1. 4 plus 1 5 minus 2, that is equal to 5 minus 2 3. That's it. Okay, so here we finished the first sum. Okay, now I'll explain this second and fifth. We just do this third one and fourth one. Okay, so I'll explain this. So given that second one, given that the polynomial is p of y is equal to 2 plus y plus 2y square minus y cube. Okay, first one, p of 0. So 2 plus 0 plus 2 of 0 whole square minus 0 cube. So 2 plus 0 plus, it also, when you multiply 0 with any number, it will become 0 minus 0. That is equal to 2. That's it. Second one, so p of 1, 2 plus 1 plus 2 of 1 square minus 1 cube. That is equal to 2 plus 1 plus 2 minus 1. The square of 1, whatever the number it was in the square, in the power for 1, it was same number. Okay, so 2 ones 2 minus 1. Okay, plus 1 minus 1 cancel. 2 plus 2 4. And the third one, that is p of 2, that is equal to 2 plus 2 of 2 square minus 2 cube. That is equal to 2 plus 2 plus 2 into 2 square means 4 minus 2 cube means 8. Why? Because 3 times we have to multiply this 2. 2 2s 4, 4 2s 8. That is equal to 2 plus 2 4 plus 2 4s 8 minus 8 plus 8 minus 8 cancelled 4. That's it. Okay, here we finished this second sum also. Here now we have this one. Okay, so you just do one thing. You just do this one, third one and fifth one you just do by your own. I'll explain this fourth. Okay, I'll explain this fourth. Fourth one, p of t, given that the polynomial is p of t is equal to t minus 1, t plus 1. So first one, p of 0, that is equal to 0 minus 1, 0 plus 1, that is equal to minus 1 into plus 1. Minus of minus, minus of plus, minus. 1 into 1, 1. That's it. Second sum, p of 1, that is equal to 1 minus 1, 1 plus 1. 1 minus 1, 0. Into 1 plus 1, 2. That is equal to 0 into 2, 0. That's it. So third sum, p of 2, that is equal to 2 minus 1, 2 plus 1. That is equal to 2 minus 1, 1 into 2 ones, 2 plus 1, 3. That is equal to 1 3's 3. That's it. Here we finish this second Roman also. Okay, you just do by your own this one. And the third Roman, verify whether the values of x given in each case are the zeros of the polynomial or not. For each and every sum he was given one x value. Look at here, x value. You have to check these values which gives the zeros or not. Okay, we have to check. Okay, for each and every sum. So third Roman, first sum, given that the polynomial is p of x is equal to, so p of x is equal to 2x plus 1, and we have to check here x is equal to, if x is equal to minus 1 by 2, is it is a 0 or not, we have to write. Okay, so p of 1 minus 1 by 2, that is equal to 2 of minus 1 by 2 plus 1. 2 cancel, so minus 1 plus 1, you just cancel this 0. So yes, x is equal to minus 1 by 2 is the 0 of the polynomial. So these sums are new for you, right? That's why I am explaining all the sums in this Roman. Next I will give the homework in the next Romans. Okay, so second sum, given that the polynomial is p of x is equal to 5x minus pi, if x is equal to minus 3 by 2. So p of minus 3 by 2 is equal to 5 of minus 3 by 2 minus pi, that is equal to 3 5's 15, minus 15 by 2 minus pi. So it's not sort out, right? So that's why it's not a 0 of the given polynomial. Here no, x is equal to minus 3 by 2 is not a 0 of the polynomial. 0 of the polynomial. Third sum, so p of x, given that the polynomial p of x is equal to x square minus 1, and we have to check if x is equal to plus or minus 1, both we have to check. Okay, that is equal to x is equal to 1 and x is equal to minus 1. So firstly we will check this p of 1, that is equal to 1 square minus 1, that is equal to 1 square means 1 minus 1, that is equal to 0. Here p of minus 1, that is equal to minus 1 whole square minus 1, that is equal to whole square means 1 minus 1, that is equal to 0. So yes, x is equal to plus or minus 1 is the 0 of the polynomial. 0 of the polynomial. So third sum, fourth sum, so that is equal to p of x, given that the polynomial p of x is equal to x minus 1 x plus 2. Okay, x minus 1 x plus 2. So here we have two terms, right? That is x minus 1 and x plus 2. So here also he was given that if x is equal to minus 1 comma minus 2. First of all we will check minus 1. Okay, minus 1 minus 1 minus 1 plus 2, that is equal to minus 2 of 1, that is equal to minus 2 into 1 minus 2. Just like that, p of minus 2, that is equal to minus 2 minus 1 minus 2 plus 2. These two are cancelled. So here minus 3 into 0, that is equal to 0. From above x is equal to minus 1 is not the zero of the polynomial, but x is equal to minus 2 is the zero of the polynomial. Okay, so fifth sum. So given that the polynomial p of y is equal to y square, if y is equal to 0, then p of y is equal to 0 square, that is equal to 0. Yes, y is equal to 0 is the zero of the polynomial. That's it. Sixth sum. So p of x is equal to ax plus b. If x is equal to minus b by a, that implies p of minus b by a is equal to a of minus b by a plus b. So you just cancel these two, then you will get minus b plus b. Cancelled. 0. Yes. So x is equal to minus b by a is the zero of the given polynomial. So next sum, that is seventh one, that is nothing but f. Given that the polynomial f of x is equal to 3x square minus 1. He was given two values for this. So first one, so if x is equal to minus 1 by root 3 comma 2 by root 3. Okay, so first one we have to check f of minus 1 by root 3, that is equal to 3 of minus 1 by root 3 whole square minus 1. Second, f of 2 by root 3, that is equal to 3 of 2 by root 3 whole square minus 1. Here that implies 3 of minus 1 whole square means 1 by root 3 whole square. Square root cancelled, minus 1. That is equal to 3 into 1 by 3 minus 1. 3 cancelled. That is 1 minus 1, that is equal to 0. Here that implies 3 of 2 square means 4 by root 3 whole square. Square for both these two, minus 1. That is equal to 2 of 4 by root, square root cancel, 3 minus 1. That is equal to 8 by 3 minus 1. That is equal to, you just imagine the denominator which has 1. So take LCM. So 8 minus 1, 3. That is equal to 5 by 3. That's it. So here, from above, x is equal to minus 1 by root 3 is the zero of the polynomial. But x is equal to 2 by root 3 is not the zero of the polynomial. Okay, here we finished this sum. Okay, we just do this without seeing also. Okay, then you will get in the better way, right? So you just understand the square roots, we have to take square for both the two numbers of this numerator and denominator. Minus 1 whole square means 1. Root 3 whole square means square root cancel, 3 you will get. Okay, just like that you just do this sum carefully. And the last sum in this Roman, that is given that the polynomial is f of x is equal to 2x minus 1. Here he gave two values. If x is equal to 1 by 2, comma minus 1 by 2. Okay, so first of all we have to check p of 1 by 2. That is equal to 2 of 1 by 2 minus 1. Just like that, p of minus 1 by 2. That is equal to 2 of minus 1 by 2 minus 1. So 2 cancelled. You will get 1 minus 1, that is equal to 0. Here that implies minus 2 by 2. 2 cancel, you will get minus 1. That is minus 1 minus 1, that is equal to minus 2. From the above, x is equal to 1 by 2 is the 0 of the polynomial, given polynomial. But x is equal to minus 1 by 2 is not the 0 of the polynomial. Okay, just like that you have to finish this third Roman. And fourth Roman, look at here, find the 0 of the polynomial in each of the following cases. In each of the following cases we have to find out the 0 of the polynomials. Already I said to you in the examples, this polynomial has to equate with 0. Okay, fourth Roman, that is the first sum, given that the polynomial is f of x is equal to x plus 2. 0 of the polynomial, that is x plus 2 is equal to 0. That implies x is equal to minus 2. That's it. X is equal to minus 2. Minus 2 is the 0 of the polynomial. Minus 2 is the 0 of the polynomial. Just like that you have to finish off this all. So you just do this one. Okay, I will explain next. Okay, so third sum, that is given that the polynomial is f of x is equal to 2x plus 3. 0 of the polynomial, that implies 2x plus 3 is equal to 0. That implies 2x is equal to minus 3. That implies x is equal to minus 3 by 2. That's it. Here minus 3 by 2 is the 0 of the polynomial. Fourth sum. So given that the polynomial is f of x is equal to 2x minus 3. 0 of the polynomial is equal to 2x minus 3 is equal to 0. That implies 2x is equal to plus 3. 2x, x is equal to 3 by 2. Here 3 by 2 is the 0 of the polynomial. Fifth one. So x square. Okay, given that the polynomial is f of x is equal to x square. So 0 of the polynomial, that implies x square is equal to 0. That implies x is equal to square root of 0. That implies x is equal to 0. For 0 there is no positive and negative, hence 0 is the 0 of the polynomial. Here sixth sum. So given that the polynomial is f of x is equal to px, but p is not equal to 0, he was given. Okay, px. So 0 of the polynomial, px is equal to 0. That implies x is equal to 0 by p. That is equal to x is equal to 0 by p, 0. So 0 is the 0 of the given polynomial. 0 is the 0 of the given polynomial. Okay, seventh sum. So given that the polynomial is p of f of x is equal to px plus q. Okay, p is not equal to 0 and p comma q are real numbers. So 0 of the polynomial is, that is px plus q is equal to 0. That implies px is equal to minus q. That implies x is equal to minus q by p. That's it. So here minus q by p is the 0 of the given polynomial. Okay, fifth sum. Look at here. If 2 is the 0 of the given polynomial, then find the value of a. Okay, so given that the polynomial is p of x is equal to 2x square minus 3x plus 7a. Here 2 is the 0 of the polynomial. 0 of the polynomial. That implies, so P of 2 is equal to 2x square minus 3x plus 7a is equal to 0. Here 2 we have to find out. Why we are equating this 0? Why? Because already he was given that 2 is the 0 of the given polynomial. That's why. So 2 of 2 square minus 3 of 2 plus 7a is equal to 0. That implies 2 into 2 square means 4 minus 3 to 6 plus 7a is equal to 0. So 2 fours 8 minus 6 plus 7a is equal to 0. So 8 minus 6 2 plus 7a is equal to 0. So that implies 7a is equal to minus 2. That implies a is equal to minus 2 by 7. Here a value is minus 2 by 7. That's it. So here in the last of this exercise 2.2, that is the last sum, if 0 and 2 or 0 and 1 are the zeros of the given polynomial, f of x is equal to, here find the values of this a and b. Okay, so sixth sum, that is given that the polynomial is f of x is equal to 2x cube minus 3x square plus ax plus b. Okay, and 0 and 1 are the zeros of given polynomial. Then we have to substitute these two. First of all, I want to substitute this one, that is first one, p of 0, that is equal to 2 of 0 cube minus 3 of 0 square plus a of 0 plus b. That implies, that is equal to 0, no? 0, already he was given that these two are the zeros of the given polynomial. That implies 2 of 0 minus 3 of 0 plus 0 plus b is equal to 0. So here these all become 0. Why? Because these all are the products. That implies b is equal to 0. You will get one value. Okay. So secondly p of 1 we have to substitute in this given one. So 2 of 1 cube minus 3 of 1 square plus a of 1 plus b is equal to 0. That implies 2 of 1 cube means 1, minus 3 of 1 square means 1, plus a of 1, a into 1, a, plus b is equal to 0. So 2 ones 2 minus 3 plus a plus b value, since b value is equal to 0, no? Already we got here. So I am taking this b value as 0 is equal to 0. That implies 2 minus 3 minus 1 plus a is equal to 0. That implies a is equal to 1. Okay. Here we got a and b values in this given sum, while 0 and 1 are the zeros of the given polynomial. Here we finished this 2.2 exercise for this polynomials, second chapter in 9th class textbook AP and Telangana mathematics. So next, in the next part I will explain the dividing of this polynomials, how to divide the two polynomials when it is given in the next part. Thank you.